general, you'll probably do okay with related rates. Usually the rates related to a product is how they're related. Right? All right. So first of all, you could start by writing the formula for the area of the circle. So what is the area of a circle? A equals what? What's that? Pi r squared, PR squared. Okay. So I have two choices now. There are two basic approaches to these types of problems. That is, I could take d dt, apply it to both sides of this equation. Okay. Or, so I'll write option one, maybe like option one there. Option one. And then option two would be find dA dr. And I already know dr dt. They gave it to me in the problem. Right? So I can find dA dr and multiply by given dr dt. Do you understand the two basic options? All right. Let's do both ways. They're pretty short. So if I take the derivative of both sides with respect to t, that is an implicit differentiation problem. Because I have r here. It's not the variable t sitting over here. I'm assuming r is a function of t. Okay? So if I take the derivative of both sides with respect to t, the left-hand side is, of course, just the symbols dA dt, the thing we're trying to find. And on the right-hand side, the derivative would slip past the constant pi and apply itself to the r squared. So on the left, on this side, option one, what you're going to do is you're going to differentiate in the usual way the outside function. So 2 comes down. Inner function r stays the same. The power goes down to 1. And I multiply by derivative of r, dr dt. Right? That would be using implicit.
And why would the 2 come in front of the r, not the pi?
Why would the 2
come in front of the r, not the pi?
The pi is in front of the r. You can write 2 pi r. Is that what?
Oh, yeah.
It doesn't matter which way, but I just did it because that was like the next thing in line.
Okay.
Yeah, certainly it'll look better with the 2's in front, yeah.
Okay.
And that one's not, doesn't need to be there either, that was just for effect. All right. So we get pi 2r dr dt using implicit differentiation. Well, we know dr dt is what? 2. Constant 2. Right? Radius versus time. Okay? So we'll go ahead and plug that on there too. So now dA dt is just as 2 pi r times 2 for dr dt, which equals 4 pi r. Now, it says at the instant the radius is 10 feet. That's the only letter I have now. So I just need to plug in 10 for r. And I'll know the change of the area with respect to time right at the moment I want when r is 10. So we get 4 pi 10. So 40 pi. What are the units? Always look at this notation for units. It's a change in area or a change in time.
Feet over minute.
Feet squared, right? This is an area. So feet squared per minute, right? The time they used was in minutes, and the measure was in feet, but it's an area. That's a linear measure, but now it's an area, so it's two-dimensional, so we have feet squared. Option 2. So since you know that dA dt is related to dr dt through dA dr, you could just take the derivative of this with respect to r, the usual thing, right? So find dA dr. Well, that's just 4 pi r. I'm sorry, 2 pi r. Which you should notice the what? Circumference of the circle?
Wait, I have a question.
Yeah. Let me say one thing very quickly. The derivative of the area of the circle is its circumference. Okay?
Where the answer is 40 pi.
40 pi feet squared per minute.
Yeah, but isn't the formula pi r squared? So, oh wait, never mind.
So dA dr is 2 pi r. But I want dA dt, but we know from chain rule version 2 in the textbook that dA dt is dA dr times dr dt. So that gives us 2 pi r times 2, which is 4 pi r, and then the rest of the problem is the same as that. Okay. So you can always do most of the time either implicitly or viewing it as a chain rule in there, a product of derivatives creating the derivative you want. It's your choice usually. Okay. Some may be more suggestive of one way or the other, may be easier to deal with, but those are your basic options. Okay. So I hope you see the rest would just be like this last part, right? This is the final thing for both of these, right? Just plug in the 10, call it a day.
Wait, okay, so what's the difference between option 1 and option 2?
In option 1, you did implicit differentiation. You did not resort to this product being dA dt. It turns out to be the same. That's that product. But you weren't intentionally trying to generate this product. You just want to find dA dt. But to do that with implicit, you need to take the derivative of both sides.
Okay.
And that gives you the 2r, and then out pops the derivative of the inner function, the dr dt.
Okay.
So it ends up looking like this, but you weren't trying to achieve this product. You were just doing implicitly, I want dA dt, I'm going to do implicit to get dA dt.
Okay.
Over here, I am trying to create that product. So I compute dA dr first, and I slap onto it the dr dt, and it's all going to read the same thing either way.
Okay.
The DRDT is representation.
That's the 2 feet per minute.
Yeah, 2 feet per minute, and what the DATR is how fast it should work, plus the rate of change of the derivative part, which is your circumference.
Correct. The rate of change of the area
Like y.
with respect to the radius gives you the circumference. The same is true of a sphere, meaning in 2 dimensions, your perimeter is called your circumference, it's a linear measure, and the inside of your circle is a 2-dimensional object, right? That's your area. If you bump everything up 1 dimension, instead of dealing with perimeter and area, you're dealing with surface area and volume, right? Everything goes up 1 dimension, you know what I'm saying?
Yeah, like if it's a cube.
Yeah. Give me a cube. Box. Anything has
It's
3
not a
dimensions.
circle.
Anything has length, breadth, and width, right? So instead of a circle, you now have a sphere. It has volume. So the rate of change of the volume is the perimeter of the sphere. What's the perimeter of a sphere called? Its surface area. That's the part that contains, right? That's the outside which contains the volume. Do you know what I'm saying, or you have no idea what I'm saying?
Yeah.
I think I'm talking crazy talk here.
It makes a little bit of sense.
What is the volume of a sphere?
Yes, good point.
Yeah. Who knows the volume of a sphere?
The what?
Come on, you're an engineer. You gotta know the volume of a sphere. You're gonna
know it.
You're gonna make a sphere sometime, right? It's 4/3 pi r cubed. So take the derivative. What's dv dr? Well, the 3 comes down, so that cancels, makes it 4. There's pi r squared. This is the surface area of sphere. Right? What's the surface area? It is the outer portion of an object which contains its volume. What's a perimeter? It's the outer portion of a 2-dimensional object which contains its area.